Hi, welcome to Wise Guys. This video is an introduction to vectors. Okay, so when we talk about quantities, we talk about them in two different ways. One way of expressing a quantity is as a scalar quantity. Another way of expressing a quantity is as a vector. A scalar quantity is a number that describes a magnitude. And magnitude is just sort of another word for the amount, all right? So it's magnitude or the number, such as 35 meters, so that's the number of meters, 15 eggs. So these are the magnitude, all right? A vector is a quantity that has both magnitude, so an amount, and a direction. An example of this is Shamir walked 40 meters. This is magnitude. Okay, the 40 meters. Shamir walked 40 meters due west. Now we have magnitude and we have direction. So this is a vector. So another example, talking about scalar and vector quantities. If we have a plane that's flying overhead, and we say a plane is flying overhead at 575 kilometers per hour. What we have here is the speed of the plane. We do not have direction, so this is a scalar quantity. And when we're talking about scalar quantities that have to do with speed or velocity, that it is called speed when it is simply the magnitude, okay? And the 575 kilometers per hour is simply a scalar quantity. If we said the plane flew at 575 kilometers per hour, 25 degrees north of east, now we have magnitude and direction. As soon as we have magnitude and direction, we have a vector. And the name of that speed, or whatever you want to call it, becomes velocity. So when we're talking about distance over time, and it's a scalar quantity, it's speed. And if it's a vector, not a scalar quantity, it is called velocity, right? And the way we express it is in this way. So we draw it as an arrow, has a tip, has a tail, and we draw it typically on the X and Y axis, showing exactly what we want to see. This is 25 degrees north, so if we say this is north and this is east, so 25 degrees north of east, and that's the way the plane's flying. Okay. Now, normally when you're trying to work through or work with vectors, you normally have more than one vector, and you're typically solving for the components of those vectors in order to add them or subtract them. So right now we're just going to walk through, or I'm going to walk through solving for the components. We can see that it's on the X and Y axis. Here's our vector. We want the X piece, so what we do is we draw a line straight down at right angles to the X axis. So then this is our X component of that vector. And then we draw a line straight across to the Y axis. And this vertical piece is our velocity in the Y direction. So here we have velocity in the Y direction, here we have velocity in the X direction. Now we can see that what we're looking at is a right angle triangle. We know the angle here, 25 degrees, and we know our magnitude. 575 kilometers per hour. So then what we do is we solve for the parts of that triangle. So let's just do that. So 575 kilometers per hour. Here's our y. Here's our x. And the arrow was going in this direction. So then the arrow for the x is going in that direction. And the arrow for the y is going in that direction. Now we know the angle here, 25 degrees. So if we want to solve, let's say for the x, we would use cos. So then the cos of 25 degrees equals our adjacent, which is x, over our hypotenuse, which is the 575. So then x equals 575 times cos 25 equals. So we have 521. Let's go with 521. So in the x direction, it's 521, and the units are kilometers per hour. Okay, so that's our x component of this vector. So right here, 521 kilometers per hour. Now, if we want to solve for the y, we will use sine. So the sine, Ashley, can I change pages? Yes, I can. So the sine of 25 degrees equals y over 575. So just to notice that again, the sine, so sine is opposite over hypotenuse, so the sine of 25 degrees is the y over the 575. So that's what we have here. We're trying to solve for y. So y equals 575 times the sine of 25 degrees. So 575 times sine of 25 equals 243. So that equals 243, and the units are kilometers per hour. So now we've solved for our x, and we've also solved for the y. So the y equals 243 kilometers per hour. So then we have our x and y axis. We had our original vector, which looked like this, which was the 575 kilometers per hour. We have the x component here, which is 521 kilometers per hour. And we have the y component of this vector right here, which is 243 kilometers per hour. And it makes sense when you think about it. We know the plane is flying in this direction, and again, this is north and this is east. So we know that there's an easterly direction to this vector, and we know that there's a northerly direction to this vector. And these two pieces we just solve for, and that's what you need to be able to do. Okay, so that video has been brought to you by Wise Guys, and I hope you have a really great day. Take care.